All right, so the last unit, we're going to be talking about gases. We talked about solids at the very beginning of the year, and then with the titration and solutions and stuff, we did liquids, and now we're moving on to the final state of matter that we are very familiar with, and it's going to be gases. Okay, so I want you guys to write down the definition of, or the description for gases on your note somewhere. But gases, basically the molecules, they move around freely. They basically fly around, and they're not bound to each other. So the gas molecules will not stick to each other. They can bounce off each other, but they'll fly around, but they will not stick to each other. So if we have like individual, let's say oxygen molecules, oxygen is O2. These O2 molecules will fly around, but they will not stick to each other, just like you see in this diagram right here. Okay. So in this unit, we're going to be talking about 4 different properties of gases. So 4 different, you can think of them as measurements because we're going to put numbers on them. 4 different measurements to describe gases. We're going to talk about 2 of them today. And then we'll learn the other 2 next time. Okay. So the first property of gases that we'll talk about today is called pressure. And make sure you guys write this down. Okay. And pressure, we use the letter P to denote it. It's basically how hard the gas molecules collide with other objects. Okay. So pressure, we symbolize it with P. It's how hard the gas molecules collide with objects. And then the way that we measure it is we measure it with different units of measurement. We can either measure it in ATM, it stands for atmospheres, or mmHg, that's millimeters of mercury. Okay, so just a quick example. You guys don't need to write this down, but we can have like 2.5 ATM. That's one way of writing down pressure. Or you can have something like 800 millimeters of mercury. So these are just ways that we measure it, and then we put numbers in the front. Okay, it's kind of like grams, pounds. We just put a number in front of the unit of measurement. Okay. So the higher the number in front of the unit of measurement, the more pressure there is. I'll give you guys another minute to copy that down. You guys don't need to copy this question down. This is just to kind of help you guys think about pressure or visualize pressure a little bit better. But you guys have probably heard that the higher you go up, the less air there is up there, right? So if you go on the top of like Mount Everest, it's hard to breathe. People need oxygen masks because there's less air. And so a way that we can measure that, we can talk about that with in terms of pressure. So at the top of Mount Everest, the air pressure is about 0.326 ATM. Okay, but in Long Beach, which is basically at sea level, the air pressure is about 1 ATM. So if you just take a look at the numbers, which pressure number is bigger, the top of Everest or in Long Beach? Long Beach, the number is bigger, right? So there's more air pressure, which is why it's easier to breathe down here. It's because the air molecules, there's more of them, and there's more pressure, so they can go into your lungs a lot easier. Okay, so that's going to be pressure. Okay, so the second property of gases is super easy. It's volume, and you guys can write this down if you'd like. Volume, we denote it with V. Okay, and it's the amount of space a gas takes up. And we measure it with something that we already know, we're comfortable with. We can measure it in terms of milliliters or liters. Okay, so volume is how much space a gas takes up, and we measure it in terms of milliliters or liters. Okay, if you wanted to do gallons, you could. If you want to do cups, you could. But for this class, we'll use milliliters and liters. Good luck, guys. Okay, so one unique thing about gases is that they expand to fill their container. So even if you have a little bit of gas, if you put it in something that's 1 liter, that little bit of gas will spread out until it fills up that entire container. So a good way to think about this is when you fart, right? It starts in one spot of the room, right? But what happens to the fart? It eventually spreads out, right, to fill the container that you're in. So in this case, it would be this room. So if I ripped a really bad one, eventually it would spread out and expand to fill this container, this room that we're in right now, right? And so the volume of the gas would be the volume, the size of this classroom. So that's what volume basically is. And gases, they expand to fill their container, okay? Any questions on pressure and volume? Pretty easy to visualize, right? I'll talk about fart a lot during this unit because that's kind of how I think about gases, the easiest way to visualize it, but more on that later. Okay, so we're going to be talking about gas things, these things called gas laws. And basically, when you change one thing about a gas, another property will change as well. So the first law we're going to be talking about today is called Boyle's law. So make sure you guys write down this highlighted part. Okay. So Boyle's law basically means if you're at a constant temperature, if the pressure goes up, if you put more pressure on a gas, the volume will go down. Okay. So the more pressure there is on a gas, the smaller it gets, and the opposite is true too. If you decrease pressure, if there's less pressure on a gas, the gas will get bigger. Okay. And then this is the equation that we're going to be using in order to solve our problems today. Just make sure you copy it down. I'll show you guys how to use it in a sec, but I want to show you guys how Boyle's law works in real life in just a second. So take a minute to copy that down, and then we'll go over it together, okay? All right, so we're just going to do this one practice problem today because I think it'll kind of convey the point. The problems today are really easy. And I wanted to give you guys some time to finish up your lab calculations if you guys aren't done yet, okay? So let me show you guys how to use this formula right here. So you're going to see that it's P1 V1 equals P2 V2, okay? So this side right here, the ones basically represent the original pressure and the original volume. So if you want to label that, okay? The ones represent the original pressure and the original volume. So what pressure and volume did our gas start at? Okay. And then you can probably assume that P2 V2, it's going to tell us the new or what it changed to. Okay, so the original, you can think of it as new, but let's use language that we've used before. This is the ending. Okay, so the original pressure and volume, and then our ending pressure and volume. Okay, so how did it start versus how did it end? Okay, so for these gas law problems, all you got to do is read the question, and every time you see a number, you just need to figure out, is it original or is it the new pressure and volume? Okay, so I'm going to go through this question with you guys, and then let's see if we could figure out which of these variables all these numbers are. Okay, so a balloon occupies 1.5 liters at a pressure of 25 millimeters of mercury. Okay, so let's stop right there. So let's start with 1.5. Is 1.5 pressure or is it volume? Yeah, it's volume. It's size, right? So this is going to be V. And then we got 25. Okay, is 25 going to be pressure or volume? Pressure. Okay. So far, so good? Okay, and then it's asking what is the volume? So we're looking for V. Okay, we don't know if it's V1 or V2. Okay, we're looking for volume when the pressure is increased to 95 millimeters of mercury. So this is obviously pressure, okay? But we can actually figure out now if this is the original or the ending pressure. If it increased to 95, is this the starting pressure or the ending pressure? This is the ending, right? So is it P1 or P2? P2, okay, which means this is going to be P1, and this is associated with this pressure, so this is going to be V1, okay? And that's it. Now we just need to plug it into our formula, and then we're all done. Okay, that's it. Super easy. All you got to do is basically figure out if is it P1, is it V1, is it P2, or is it V2? Okay, any questions on why each of these numbers are those variables? Hopefully it's pretty self-explanatory. Okay, so let's plug in our numbers. So P1 is 25, so we're just going to write 25. Okay, millimeters of mercury. Oh, one thing I did forget to mention, make sure that when you guys put in the P on both sides, they have to have the same unit of measurement, okay? So just keep that in mind. The P's need to have the same measurement on both sides. Okay, V1 is 1.5 liters, so 1.5 liters. And then that's going to be equal to, okay, P2 is 95 millimeters of mercury. Okay, so again, this works because you have the same unit of measurement. They need to be the same. And then we are solving for V2. Okay. Okay, so this is a very easy problem. All we need to do is rearrange the numbers, and then that'll let us solve it out. Okay. Okay, so let's go through the calculation. So we want to make V2 by itself, right? So what we're going to do is we're going to have to move this 95 to the other side. Now, if you guys take a look at this, what are we doing with the 95 and V2? Are we multiplying, dividing? What are we doing? If they're next to each other with parentheses. Yeah, they're being multiplied, right? So if I want to move the 95 to the other side, what do I have to do with the 95? You got divide by 95 on both sides. Because if you divide by 95, that's going to allow you to cancel out the 95 right here. Okay. So you want to divide both sides by 95. Okay. After that, you just plug and chug into the calculator. Remember, multiply the things on the top, divide the bottom. So on your calculator, you're just going to plug in 25 times 1.5 divided by 95. And that will give you your final answer. Okay, so see if you guys can punch that into your calculator, see what you guys get. And then see if you guys can figure out what letter to put behind the number. So it's going to be liters, milliliters, mmHg. What do you put after the number? Okay, so for the calculations, you do 25 times 1.5 divided by 9.95. Oops, not 9.5, it's my fault. 25 times 1.5 divided by 95, and you should get 0.39. Okay. So the final answer will be 0.39, and since we're talking about volume, this should be liters. Okay, and that will be your final answer. Okay. And that's how you do basically all of the Boyle's law problems for your assignments today.